Hello again. So far, we've done several techniques in differentiation and taking derivatives. We did the chain rule, we did the product rule. Now we're going to introduce a new technique that's for functions that are divided. Basically, we have a quotient, and it's called the quotient rule. It also has a similar formula, like the one for the product rule. So let's see what it looks like, and let's solve some problems. So that's what we did before. All of these was either x to a power or the sines, cosines, all the arguments of those functions were just x. Then we expanded that to, okay, some problems don't just have x in here, they have functions of x. We call that a function u. And then we did the chain rule right here on all of these. Then we said, okay, we can just have standalone functions together. We could have functions multiplying each other. What is the rule for that? And here, if we have two functions multiplied, the derivative is derivative of the first times the second plus the derivative of the second times the first. And now the quotient rule. If we have two things divided that we cannot simplify, although, as I'll show you later, this, in a way, is another form of the product rule. But if you have f over g, then the derivative of the quotient is derivative of top times bottom minus derivative of the bottom times the top divided by the bottom squared. Okay, so let's see how we solve these problems. So here we have two things divided. I'm going to call this f. We're going to call this g. All right. So I have y equals f over g, then y prime. From the definition, derivative of top times the bottom minus the derivative of the bottom times the top over the bottom squared. F prime. F is 2x minus 4, so 2x minus 4 prime times g minus g prime. G is 3 plus 2x times f over g squared. What's the derivative of 2x minus 4? That's a straight line. Its derivative is its slope. It's 2 times 3 plus 2x minus the derivative of 3 plus 2x. Again, that's a straight line. So its derivative is its slope, 2x minus 4, over 3 plus 2x squared. So here, multiply things out. 6 plus 4x minus 4x minus 8 over 3 plus 2x squared. The 4x's cancel out, and we have a negative 2 over 3 plus 2x squared. Right? Let's do another problem. Again, here it looks like this is my f, and that's my g. G is the bottom, f is the top. So, write definition, y prime, f over g. Sorry, if y is f over g, then y prime is derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So the derivative of the top, where's the top? Right here. E to the 2x plus e to the negative x prime. That's f prime times g. Tangent squared x plus 4 minus derivative of the bottom, tangent squared x plus 4 prime times the top over the bottom squared. All right. So what's the derivative of the top? I mean, this one right here. This is the derivative, basically, of e to the 2x plus the derivative of e to the negative x. That's what that is, the first one. They're individual derivatives. Here's tangent squared x plus 4 minus, remember yesterday, in the previous video, we had cosine squared, I think, of something. So this is the same as tangent x squared. Okay? So the first thing we see here is a power rule. The derivative according to that is you drop the power, that thing that was raised to the power, right? We reduce its power now, times its derivative. So we did a power rule here, because this was tangent squared x over the denominator squared. Now what's the derivative of e to the 2x? Again, chain rule. The derivative of e to the 2x is itself times the derivative of its power, plus derivative e to the negative x is itself times the derivative of its power, or the exponent on it. And here we have tangent squared x plus 4 minus, here what do we have? 2 tangent x times the derivative of the tangent. So 2 tangent x. What's the derivative of the tangent? That's the secant squared x. E to the 2x minus plus e to the negative x, all over tangent squared x plus 4 squared. So the derivative of this is 2. So you have 2 e to the 2x. Derivative of this is negative 1 times the tangent squared minus 2 tangent secant squared, right, over this tangent. Okay. Simplifying will make it a little bit more involved. All right, but this is good. This is good. Keep it like this. All right. So that's the solution to this problem. All right, let's look at this one. Again, this is my f over g right here. So y prime is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. The top is x squared tangent x prime times the bottom minus the derivative of the bottom times the top over the bottom squared. Well, let's take the derivative of this now. What do we see here? Again, we don't see an x squared. We don't see a tangent by itself. We see two things multiplied, which means I can take this as my w and my v and use the product rule, right? These two are multiplied together. Remember what the product rule says? Let's write it out. Derivative of the first times the bottom plus the derivative of, the first times the second plus the derivative of the second times the first. This is here. Times the x plus 1 minus. What's the derivative of x plus 1? It's a straight line. Its slope is 1, so the derivative is 1. over x plus 1 squared. So what's w prime? That's x squared prime times tangent x plus tangent x prime times x squared. So this, so that will highlight or not, probably not. This thing here in yellow is all of this here. That's what it translates to. Okay? Times x plus 1 minus x squared tangent x over denominator squared. Derivative of x squared is 2x. Derivative of tangent x secant squared x times x squared. I like to put the x squared in the front. Minus there it is. Okay, we can factor an x out, maybe. We can write the tangent, as a secant sign and take a sign out, but that's all algebra at this moment. That's where we want to get to. This is taking the derivative using the quotient rule and the chain rule and the product rule. They're all together in this one. We had a quotient, then we had a product, and with the product, we have a chain rule. Okay. All right, this one. And that's f over g. So y prime is f prime g minus g prime f over g squared. F prime, we have cotangent 3x minus 4. Derivative times the bottom minus the derivative of the bottom times the top over the bottom squared. When I square the 1/2, it goes away. All right, let's talk about the cotangent. So the cotangent of something, what is its derivative? It's the negative cosecant squared of that something times the derivative of that something times x 4 plus 2 to the 1/2. So this is this. Right? We're just applying the chain rule on the cotangent. Then derivative of this, again, we have a something to a power. So we drop the power, something to 1 less power times the derivative of that something. Cotangent 3x minus 4. All of this is over x to the 4 plus 2. So let's worry about the first derivative here. What do we have? 3x minus 4. Its derivative is 3. That's a straight line. Its slope is 3. So here's, I pull it out. Negative 3 cosecant. Then I have x to the 4 plus 2 to the 1/2. Plus 1/2 x to the 4 plus 2 to the negative 1/2. What's the derivative of x to the 4 plus 2? That's 4x cubed plus 0, or 4x cubed. Cotangent 3x minus 4. So we can get a common denominator here of 1/2 x to the 4 plus 2 square root, and then combine it with this. Will it do anything? Maybe not. But here's how it will look if we do that. So we'll have 2 square root of x to the 4 plus 2. Actually, we can combine it with the 1 in the denominator. Just leave it like this for now. And this will go away, so it's -3 cosecant squared 3x minus 4, x to the 4 plus 2. The half goes away. And then here I have a plus 4x cubed cotangent 3x minus 4. In the denominator, we can combine to give me a 3/2. And that's what I will leave it. Okay, that's what I'll leave it. This is a good stopping point. Well, let's look at this here. Let's rewrite this. I wrote that square root as power 1/2. And this is the same as f over g. So y prime is derivative of top times bottom minus derivative of bottom times top over bottom squared. So let's see. Top is 3x minus 2. 3x minus 2 prime times the bottom minus derivative of the bottom times the top over bottom squared. When I square the square root goes away. So let's take derivatives here. What's the derivative of 3x minus 2? That's 3. Straight line, slope. Now, what's the derivative of this? Again, here we see something to a power. So we take the derivative of that something. So that's 1/2 x squared plus sine 2x to 1 less power times the derivative of that something. Then we have the 3x minus 2 lingering. And we divide this by x squared plus sine 2x. All right. We got to take the derivative of this now. Okay. So let's do it. This is 3 square root of x squared plus sine 2x minus 1/2 x squared plus sine 2x to the negative 1/2. So that's like 1 over the square root. Now, what's the derivative of that thing right here? So the derivative of x squared is 2x plus. Now I'm taking the derivative of the sine, and I see it's the sine of something. So the derivative is the cosine of something times the derivative of that something times 3x minus 2 over x squared plus sine 2x. Now remember, this is in the numerator. When I change it to 1 over the square root, I can get a common denominator and then combine it with this. When I do that, this will be 3x squared plus sine 2x. The square root goes away. The 1/2 is going to go down in just a second. And here I'm left with 2x cosine 2x times the derivative of 2x, which is 2. So it's minus 4. This 2 and that, no, not yet. Keep it like this. And we have 3x minus 2. In the denominator, I just brought down a square root. I brought down this guy. Okay. So this is negative 1/2, 1 over the square root of that. But it's an numerator. And when I get a common denominator, I bring it down, and now it adds to the bottom. And maybe factor a 2 out from here, just to be consistent, I guess. And there's the answer. You can try to simplify, but nothing will cancel out really. Maybe the x squared will combine. Here I have negative 6x squared. Here I have 3x squared. But beyond that, we cannot really simplify a whole lot. All right, let's look at this again. That's looks like a complicated or involved quotient rule. So let's do it. So this is again f g. So y prime is f prime g minus g prime f over g squared. All right. F prime. We have x squared sine x plus 4 x minus 2 squared prime times the bottom plus derivative of the bottom times the top. Over the bottom squared. All right. Now, here things are really complicated. We got a lot of terms here. Okay, and we got product rule here, and this is a long derivative. So what we do, the best thing to do is to take it and do it on the side. So let's take x squared sine x plus 4x minus 2 squared prime equals. It's a derivative of this plus the derivative of the second one. So let's write it out. All right. Let's look at the first one. What do we have on the first one? You've got an x squared and a sine. This is like a product rule. So this is w, this is k. So the derivative of this is derivative of the first times the second plus derivative of the second times the first plus, what do I have here? I have 4 to a power. I don't care what the power is. I have 4 to a power, 4 to a function of x. The derivative is the ln of 4 times 4 to that power times the derivative of that power. Okay? That's the chain rule. Ln of 4, 4 to the function times the derivative of that function. So let's write what w prime is. That's x squared prime sine x plus sine x prime x squared plus ln of 4 times 4x minus 2 squared times. What's the derivative of this right here? Again, we see here something to a power. Power rule, some function of x to a power. That's different than the 4 to a power. The base of the 4 was a constant. The base of 4 to the x or 4 to this power was a constant. Here we have a function of x to a power. So the derivative is drop the power to 1 less power times the derivative of that thing. So we have x squared, derivative is 2x sine x. Derivative of sine x is cosine x times x squared. I'm going to put it here. We don't need these anymore. Plus derivative of x minus 2 is just 1. So plus ln of 4x minus 2 squared times 2x minus 2. Like this. Okay? And this is just this. Now let's do this. And then we'll go in and plug them in. Okay? So here we have 3x plus ln of x squared plus 1 prime. Again, that's a derivative of the first plus the derivative of the second because they're added. So I add their derivatives. Derivative of 3x is 3 plus derivative of the natural log of something is the derivative of that something over itself. And again, ln of u prime is 1 over u times u prime. The derivative of that something over itself. There it is. So that's 3 plus derivative of x squared plus 1 is just 2x, because the 1 gives me a 0 over x squared plus 1. Maybe get a common denominator. So 3x squared plus 2x plus 3 over x squared plus 1. That is the derivative of the natural log right here. This, run this thing, is a derivative of this. So now we can plug them in. To be careful. So this is the ln 3x plus ln of x squared plus 1 squared. And on the top, I have this. So let's write it 2x sine x plus x squared cosine x plus, I'm going to bring this to the front, 2x minus 2 ln of 4 to the x minus 2 squared. That was just a derivative times this. Minus the derivative of the natural log. And you know, this right here, 3x plus the natural log. It was this one right here. So this is 3x squared plus 2x plus 3 over x squared plus 1. Then times the top, which is x squared sine x plus 4 to the x minus 2 squared. And there it is. Honestly, I will just keep it like this. I will not mess with it. Again, the idea is not to simplify y prime. The idea is to give you example of, in this case, we had a product rule. We definitely have the chain rule. We have a quotient rule. So that's how we solve these. And then simplification, if necessary, then we have to do it. All right. Now, I mentioned at the beginning, just real quick, that the quotient rule is similar. I mean, you could use the product rule instead of the quotient rule. So let's say we have y equals 3x plus 1 over x plus 2. Okay. And the first look at this, you could say, oh, this is f over g. Let me go ahead and do y prime as f prime g minus g prime f over the bottom squared. And then what you'll have is 3x plus 1 prime x plus 2 minus x plus 2 prime 3x plus 1 over the bottom squared. and then go ahead and do it. But what we can also do sometimes in some problems, maybe not in this one, but in some problems, I can rewrite y as 3x plus 1 times x plus 2 to the negative 1. Right? I bring this up. And now what do I have? I have a product. Here's f, here's g. So y equals now f prime g plus g prime f. Okay? So what is f prime? It's 3x plus 1 prime times x plus 2 to the negative 1 minus a plus x plus 2 to the negative 1 prime times 3x plus 1 over x plus 2. No, that's it. Just like this. Because I'm doing this now. Okay? Now let's take the derivative of that. All right? So this is again prime. 3x plus 1, its derivative is 3. X plus 2 to the negative 1. Let's just put it over x plus 2 plus derivative of x plus 2 to the negative 1. Again, something to a power. We drop the power. X plus 2 to 1 less power times the derivative of x plus 2. Okay? Times 3x plus 1. Here we have 3 over x plus 2. The minus. Derivative of x plus 2 is 1. 1 times 3x plus 1 is 3x plus 1. And I bring this down. And now if you want to get a common denominator, you'll have 3 times x plus 2 minus 3x plus 1 over x plus 2 squared. Of course, we can simplify. We'll get 3x plus 6 minus 3x minus 1 over x plus 2 squared. These cancel. Gives me 5 over x plus 2 squared. If we do this real quick, the derivative of this is 3. Here's the x plus 2 minus the derivative of this is 1 x plus 1, 3x plus 1. 3x minus 3x goes away. 6 minus 1 is 5. I get 5 over x plus 2 squared. Okay. So obviously we're going to get the same thing, but in this case, this took longer. This problem is not ideal for it. But I just wanted to show you that in some problems, it may be beneficial to change a quotient into a product by bringing the denominator up and then do the product rule. Sometimes it gets to simplify things. Not in this case, but these two are in a way similar. Okay. This one did not require much work on the quotient. Okay. These problems were easy. It was too much work to do the product rule for this one. Yeah, we got the same answer, but we took longer path. But sometimes you may see problems that you, if you think about it for a few seconds, say, oh, maybe it's advantageous to do product rule. Let me bring it from the bottom up, put a -1 on it, and then work it out. Okay. And that is it for the quotient rule. Next, we're going to apply these rules to solving the tangent problem, doing implicit differentiation, then doing logarithmic differentiation, then move on to related rates and optimization problems, right? So all the topics I just mentioned depend on basic derivatives, chain rule, product, and quotient rule. I hope to see you there as I continue working these out. And please comment in the comment section about any issues or anything you'd like to see in these videos. All right? Thank you for your time. Hope to see you later.